Greetings, ladies and gents, and welcome back at Mike Mating Science Club. It's been a while, last since I posted videos. It's just that I've been having issues with my cell phone. Yeah, with the camera, it was not actually working properly, so that's the reason why I kind of stopped making videos. But I'm back, eh? So today we'll be looking at a question which was written in November 2020. Now, unfortunately for the grade 12s, we are actually at the end of the year if you are in 2025. So since I'm not gonna have enough time or any time, of course, to cover the lessons on every topic, so what I'll be doing in this case, I'll be walking you through as much past papers as I can, and I will be explaining certain parts where I feel like this is actually the part that you really need to know, so that you can be ready to take away any question when the situation rises in the exam. So for question two, without wasting any time, they say that a 20 kg block resting on a rough surface is connected to block P and Q by a light inextensible string moving over a frictionless pulley. So in this case, that statement, the frictionless pulley, simply implies that in this case that pulley does not contribute anything to our system, meaning that it doesn't disturb our system. So in this case, if we find the tension here to be, let's say, 20, so in this case also in that other side would also be 20. So if it's 30 here, it would mean that it is also 30. So in this case, it doesn't it doesn't disturb our system. So if it doesn't disturb it in a way that, let's say, if we find that the tension here to be 20 and here it would be, let's say, 15. So in this case, it doesn't disturb our system, meaning that whatever tension that we find on this side, it would be the same tension that you would find in this side. So if you find this to be 20, so in this case, you would know that also the tension on this side would also be 20. So that's what they mean that by that frictionless pulley, meaning that it doesn't contribute anything to our system. It doesn't disturb it in any way. So they say that block P and Q are glued together and have a combined mass of M. They say that a force of 35 Newton is now applied to the 20 kg block at an angle of 40 degrees, with the horizontal as shown below. They say that the 20 kg block experiences a frictional force of magnitude 5 Newton as it moves to the right at a constant speed. Now, they say the statement constant speed is simply implying that our system is not actually accelerating, so it has the same speed. So in this case, the acceleration in this case it is zero. Right, so that's one thing that you must note now. Now I know sometimes it's quite a little bit annoying to read the statement, but there's nothing you can do. What they do is that they hide most of the information. So in this case, for 2.1, without wasting time, they say that define the term normal force. So the formal definition for normal force. So normal force is a force that the surface exerts on an object that it is in contact with and which is perpendicular to the surface. So that's the formal definition of normal force. So a normal force is a force that a surface exerts on an object that it is in contact with and which acts perpendicular to the surface. So that's that's the definition, the formal definition for normal force. So for 2.2, they say that draw a labeled free body diagram for the 20 kg block. Now, whenever they ask for you to draw a free body diagram, if there is a need for you to resolve components, do not give them the one that has components, but rather give the one that does not have components. So in this case, you just put forces in whatever direction they're in. So what I mean by this is that now if you look at that 20 kg block, we know that we have, I'm just gonna draw it down here. So in this case, this would be 2.2. So in this case, what I mean is that now if we look at that 20 kg block, we know that we have normal force, right? So we have our normal force. We also have the force of gravity, Fg, and we also have the friction. Now remember that our object is actually moving in that direction. So in this case, our frictional force would be opposing that motion. So in this case, we would have the friction, Fk, and in this case, now remember, we also have tension, so that would be tension. But remember that we also have that force applied at an angle. So what I meant by that, you must just draw it as it is without components, is that do not resolve that 35 Newton, that force that we have there. So what you would do, you just draw it at that angle angle there. So in this case, so this would be the force applied. So this would be the type of the free body diagram that you would actually give them, not the one with the components, but the one without the components. So in this case, for 2.3, they say that calculate the combined mass M of the two blocks. Now, remember what I said. I said that whatever tension that you find in this on this side, it would actually be the same, right? The tension, of course, that you find. So in this case, if you find the tension on that in this side to be 20, so that would also mean that on that side it is also 20. So in this case, in order for us to calculate that mass M, now what we would need to do there would be to use Newton's laws. So in this case, now remember, we know that of course our object is not acceleration, right? So in this case, we know that F net would be equals to ma. But remember that we know that it is not accelerating. The acceleration would be 0. So in this case, we would know that of course F net would be equals to 0. Now this would be for that block M. So that would be for the M kg block. So in this case, what I'm going to do now, remember, how many forces do we have acting on that block? P, let me just say PQ. So in this case, what we have the tension, right? And we also have the force of gravity. So in this case, what I'm going to say is that I'm going to say F. Now remember, when we say F net, in this case, we are taking the sum of the forces that are acting in a particular dimension. So what I'm going to do, I'm going to say F net is equals to ma. Now in this case, I'm saying, now what I'm going to do, I'm just going to choose downwards is positive, so that would mean upwards would be negative. Right, so what I'm going to do, I'm going to say Fg. Now remember, we said we have the force of gravity, right, acting on that object. So in this case, we would have Fg, right, minus that tension there. So that would be equals to 0. Now to calculate Fg, now remember, to calculate Fg, would say mg, right? So in this case, it would be that would have the mass, which we don't know, right? But in this case, we know that gravitational acceleration value to be 9.8. So this would be 9.8 minus tension. So this would be equals to 0. Now, as you can note, I'm actually trying to calculate for that mass, but in this case, I do not also know the value of tension. So what I'm going to do, I'm going to leave that right there, and then I'm going to try to find out that value of tension. Now, if you note on that block, that 20 kg block, so what we now, another thing that I must mention, now whenever you are performing calculation, you must use the free body that has components. So this would be, of course, for your own sake when you are performing calculation. So if they ask for a free body diagram, right, give them the one without components, but in this case, just draw a rough free body diagram on the answers on the question paper itself, so that so that things can become easy when you're of course performing calculation. So what I'm going to do for my own sake, I'm going to erase that F there. So this would be, it would be me, of course, writing it on that question paper. Now, if I resolve that 30 Newton, what I would have, actually, I would have FA perpendicular, right? So that would be FA perpendicular, and I would also have FA parallel. So this would be FA parallel. Now to calculate FA parallel, so what you would do, you would say, so for FA parallel, so this would actually be equals to FA multiplied by cos of theta. And of course, to calculate FA perpendicular, So it would be equals to FA multiplied by sine of theta. So that theta would be that angle, that 40-degree angle there. So what I'm going to do, I'm going to calculate that tension there using that 20 kg block. So what I'm going to do, I'm going to say F net is equals to MA. Now we know that of course our block is not accelerating now. Now remember, we said we took downwards as positive, right? So going downward would be a positive. So in this case, going in that direction, it would be negative. And then of course we know that going that direction, it would be a positive. So what I'm going to do, so in this case, I would know that of course that force applied there, it would be negative because I chose going downwards as positive, right? So in this case, going this direction, it would be negative, and then of course going that direction, in this case it would be positive. So in this case, let me just erase that. So in this case, what I would have in this case would be my tension being positive, all right, because it is pulling my object to the right. So in this case, it would be T minus my F A parallel minus FK. Now remember, they said that's a rough surface, so this would be equals to 0 because we know that of course our system is not accelerating. There is no change in speed or velocity. So in this case, it would be T minus, and of course to calculate FA parallel, so that would be equals to FA, right, that force. So it would be 35 multiplied by cos of 40 degrees minus, now remember the friction, before they say that that's 5 newtons, so that would be minus 5, so that would be equals to 0. And then of course to find tension, so tension would be equals to 35 multiplied by cos of 40 degrees plus 5. So in this case, let's see what we're gonna get. So we have 35 multiplied by cos 40 degrees plus 5. So in this case, we have tension being 31.81155, and of course some other decimals. So what I'm going to do in this case, I'm not going to round that off. I'm just gonna keep it from this step here. So in this case, in terms of T, I'm just gonna write 35 multiplied by cos of 40 plus 5. So in this case, that tension there, I'm just gonna replace it with 35 multiplied by cos of 40 plus 5. So in this case, we know that of course it is equivalent to that 31.81555, and of course those are other decimals. So what I have now would be the mass multiplied by 9.8 minus 35, right, minus 35 multiplied by cos of 40 plus 5. So this would be the value of tension. So this would actually be equals to now I'm running out of space, so that would be actually be equals to 0 there. Sorry for squeezing that there. Now remember that tension would be 35 multiplied by cos of 40 plus 5. So that's why I actually put it in bracket. So in this case, so that I don't make the mistake of thinking that only that 35 multiplied by cos of 40 is the one that's negative. But in this case, we know that of course this whole thing that we have here would be the one that is negative, not only that 35 multiplied by cos of 40. So in this case, what I would have now, what I'm going to do, I'm going to transpose that negative 35 multiplied by 40 plus 5 to the other side. So in this case, I will be left with m multiplied by 9.8. So this would be actually equals to, now remember, when I transpose it to the other side, it becomes positive, right? It was negative, now it becomes positive. So in this case, this would be positive 35 multiplied by cos of 40 plus 5. So in this case, what I would have there, I'm just gonna what am I doing now, right? So in this case, what I would have there now, what I'm going to do next, I'm just going to divide everything by 9.8. So in this case, I'll be left with m being, so what we have, so we have 35 cos of 40 plus 5 divide by 9.8. So in this case, we would have a mass of 3.25 actually not Newton. So that would be 3.25 kg. So that would be kg. So that would be, of course, the mass of that combined block, which we have as P and of course and Q. So in this case, so that our M of course would be 3.25 for that. So that would be how you would actually get that 5 marks. So for 2.4, they say that at a certain stage of the motion, block Q breaks off and falls down. How will each of the following be affected when this happens? Now, they said that what happens to the tension in the string. Now, what would happen to the that tension would actually decrease. Why? Because in this case, we know that now we have actually less mass. Now, so since we have less mass, so that would mean also that tension would actually also decrease. Now, if you have, let's say, a box that is full of, let's say, things inside there, and then some of the things, let's say you are actually holding it using a rope. Now, let's say some of the things inside that box falls down. So in this case, you would actually start to feel that tension it actually becomes less. So in this case, so the same thing would happen. So now we know that some of the things that we had falls down. So that would mean that that tension would actually it would actually decrease in this case. So in this case, the answer for that 2.4.1, so the answer would be decreases. So for 2.4.2, they said that how will each of the following be affected when, of course, when block Q breaks off and falls down. So what would happen in this case to the velocity of the 20 kg block? Explain the answer. Now, we know that our block is moving in that direction. Now, I want you to think of this now. Suppose I'm just going to use the same example. Now, suppose, let's say, you were pulling, let's say, a box that is full of things again. But in this case, you're trying to pull it up, let's say, a slope. But in this case, the mass or the force acting on that block is actually greater than the one that you are actually applying to that object. So in this case, that object will actually be pulling you right in the other direction. But once some of the things that are inside the box falls off, so in this case, you would actually have kind of feel like you have more power. In this case, of course, in this case, you would feel like that force that you actually that you are putting in that system is now greater. So in this case, so that would mean that the velocity of the object would actually now decrease. Why? Because now your force in this case is kind of greater than the one which was acting in that object, while there was some of the things which had fallen off inside that block or that box. So in this case, for that, so what would happen to the velocity of the 20 kg block? So in this case, it would actually increases. It would actually decrease in this time. Now, if you were actually looking at it from the perspective that is traveling in that direction, so in this case, the velocity would actually decrease as because we know that, of course, that tension in this case, so in this case we no longer have tension. So that would mean that, of course, that in this case we now have more force, of course, acting in that direction. So that would mean that, of course, that velocity now decreases. So for that, for explain your answer, so in this case, how you would actually explain your answer would be, now remember we said that, of course, the velocity decreases, right? So in this case, as the tension force decreases, the net force in this case, so the acceleration acting on in the opposite direction of the motion would actually kind of increase in this case. So in this case, we would have more force acting in that direction. So that would mean that, of course, that velocity acting on that object would actually decrease. So in this case, so that would be, so the force, of course, acting on that block would actually, of course, acting in that direction, it would increase. So in this case, so that would mean that we would, in some sort, pulling that block upwards. So that would mean that, of course, it would slow down. So in this case, as a result, the velocity would actually start to, to decrease. So in this case, so that would be the answer for that 2.4.2. So that would be all for this question. So if this helped you at some extent, please be sure to like the video. And of course, if you have any more question, you can always ask in the comment section. And if there's any past paper that you would love me to cover, please, you can always suggest it in the comment section. I'll make sure that I cover that past paper. But as the story always ends, ladies and gentlemen, this is Sir Mike signing out. Sharp, sharp.